In this video, we are going to show you how to graph polar equations. Right, so this is kind of the detail. We need a bunch of little pieces to this, and there's eventually kind of a shortcut to it. But here's what this stuff looks like, and here's how you get about it, and then we can deal with the shortcut thing. So we're looking to graph r is equal to -3 sine theta, and so we're going to plug in a bunch of values, plot a bunch of points and see what's going on. So I'm going to start plugging in basically 30, 45, 60, 90. So I'm going to do pi over 6. We'll do pi over 4, pi over 3, and pi over 2. So we have a 30 degree, which is this line right here. And then we have the pi over 4, which is going to be like right here. And then pi over 3, and then the pi over 2. So we're going to take pi over 6. We're going to do sine of pi over 6 times -3. So what I've kind of prepped here is if I do sine of pi over 6, I'm really doing sine of 30. So sine of 30 is 1 over 2. So it's going to be -3 times 1 over 2, which is -1.5. All right, so that is our distance out from the origin. So at 30 degrees, we are 1.5. Whoops, we are -1.5. So we are being reflected. So we should be at 1.5, but we're being reflected over onto the other side because of the negative radius. Then we'll do pi over 4. And so if we're doing pi over 4 is going to be sine of 45, which is 1 over root 2, or root 2 over 2. So we would take -3 times root 2 over 2. And if we plug that into a calculator to give us a distance, that would get us about -2.1. So same thing. So this time at 45, we are just past 2, but we're being reflected over. So it's sitting right there. Then if we did pi over 3, that's 60. So we're doing sine of 60. So root 3 over 2 multiplied by -3. So -3 times root 3 over 2. And if you threw that in a calculator, that would get you a -2.6. So same thing. Now we're at 60 degrees. We should be at 2.5-ish, 2.6, but it got reflected. So then we're down here. And then pi over 2 is 90 degrees. So we're doing sine of 90 degrees and sine of 90. If you remember, we are looking at sine of 90 is the y value. So we have a 1. So we're doing -3 times 1 equals -3. So at 90 degrees, we are reflected down to a distance of -3. All right, so far we've kind of wrapped around to here. All right, so let's keep going. So if we kept going with this, this would be 2 pi over 3. So 2 pi over 3 is actually going to be equivalent to pi over 3 because you have the same reference angle. The signs are still positive in here. So you're going to get the exact same thing as -3 times root 3 over 2. So that's still going to be -2.6. So this point right here that should have been up here got reflected over at the same value as that one. And then we would do 3 pi over 4. Well, 3 pi over 4 is going to be the exact same thing as this one. So that's going to be -2.1. So it should have been here, got reflected. And then we would do 5 pi over 6 because this is 1, 2, 3, 4, 5 pi over 6. Same value as up here. So we would get a -1.5. So on this line would be at a -1.5. And then our last part of this pattern, we would just go to pi. And so if we plugged in pi, we would be doing sine of pi. And so sine of pi is we are grabbing the y value, which is 0. So we would take -3 times 0, which is going to get you a 0. So that would mean this graph would come out and then come back. And then at pi, we would be at a distance of 0. So it would kind of suck it back into the origin. So then we would go now to 5 pi over 6 pi. So 6 pi over 6, 7 pi over 6. 7 pi over 6. And if we did 7 pi over 6, we have the same reference angle. So it's going to be a negative 3. We're doing 30 degrees. So sine of 30 is 1/2, but we would be in the third quadrant where now sine went negative. So we'd have a negative 1/2, right? So now all of a sudden the negative and the negative equals a positive 1.5. So we're not reflecting anymore. So when we're at 7 pi over 6, we're actually at a distance of 1.5. And then you're going to see that that's going to keep on playing out for the second kind of half of these, is that all of these values, these sign values are going to be negatives times that negative. And so you're literally going to have a repeat in these values. And so this one went to 1.5. Oops. Here's kind of where everything repeats. And so we'd have a positive 1.5. This 5 pi over 4, we'd have a positive 2.1 because you'd have a negative times a negative because of the quadrant that you're in. And then you'd have a negative, or you'd have a positive 2.6. And so what would end up happening is you just get a repeat of these values over and over and over again. And in fact, let's skip down to, let's see, that would be 5 pi over 4. And then it would be, so 6 over 6, 7, 8. 4 pi over 3 would be this one, right? Because that one corresponds with that one. So if you went to 3 pi over 2, just to kind of validate that it should give us a distance of positive 3, we would take negative 3 times sine of 3 pi over 2, which would be a negative 1. And that would equal a positive 3. So at 3 pi over 2, we would be at a distance of 3, right? It's not reflected over. So that would create this circle and just repeat itself over and over and over and over and over again. All right, so that is us doing the first polar equation, graphing it, and then this one's going to get a little bit more complicated because the period is going to be adjusted.